Let's look at another example for the extreme value theorem. In this case, we're taking the function x squared over x minus 2 on the interval 3 to 7. Now, as always, make sure you evaluate the endpoints. In this case, x squared is 9 over 1, so at 3 it's 9, and at 7 it is going to be 49 over 5, 9.8. So we know the values at the endpoints. The question is, between these two endpoints, is there a critical value in the derivative, right? So let's take a look. What is the derivative? So q prime of x, using quotient rule, I'm going to start off with 2x, derivative of the top times the bottom, minus the top times the derivative of the bottom, which in this case is 1, all divided by the denominator squared. All right, and so this is going to be, if I can do algebra, 2x squared minus x squared. So that's going to be x squared minus 4 over minus 4x, pardon me, over x minus 2. Well, this clearly has a 0 at, let me write it a little bit differently, right? I can write this as x onto x minus 4 over x minus 2, right? So clearly it has a 0 at x equals 4, so there's critical value. At 4. So what is the derivative at 4? It's 0, right? Then what is the second derivative at that point? So if we start looking for the second derivative, or we start looking at what is the first derivative on either side of x equals 4, let's just go with that. The first derivative at just below 4 is negative because this term is negative, that's positive, that's positive. First derivative just above 4 is positive because this becomes positive and those are still positive. And on this whole interval from 4 down to 3, it remains negative. From 4 up to 7, it remains positive. That tells us that we have a minima, an absolute minima at 4, and there the value of the function is 16 over 2 is 8. And from the endpoints, and this is the part you got to remember, easy to forget, we have an absolute maxima at 7, or q of 7 type is 9.8. And that gives you your absolute minima and your absolute maxima of this function x squared over x minus 2 on the interval 3 to 7.